Hi everyone. Today we're going to be converting decimal numbers to binary. Well, first of all, what are decimal numbers? They are the numbers that you and I are used to using every day. And they look something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on. That is how we are used to seeing the numbers written. But computers don't think like that. Computers only think in terms of off and on, which usually we write as 0 for off and 1 for on. So using just those two numbers, how can we possibly represent all of these? Well, let's find out. So in the decimal system, we're used to seeing numbers in very specific positions. So this first position is the units. You're used to seeing 1, 2, 3, 4, 5, 6, 7, 8, 9 in there. This position is the tens. So if I have a number like 29, that means I'm using 9 units and 2 tens. The next one is the hundreds. The next one is the thousands, and so on and so on and so on. Every spot means I'm going up times 10. If I have 5,329, I have 5 thousands, 3 hundreds, 2 tens, and 9 ones. And so on and so on and so on. So say I have a friend who's trying to get to the top of this building, and it is exactly 22 feet tall. So if we think of this in decimal, we've got a bucket of ladders that are 10 feet tall and a bucket of ladders that are just 1 foot tall. This is our tens and these are our ones. So I'm not going to need any 100-foot ladders because I'm only going up to 22 feet. So in order to get there, I'm going to take 2 from my tens ladders. So I got 1, 2 10-foot tall ladders. And I'm also going to need 2 for my 1-foot tall ladders. 1, 2. And that gets me right to the top. And my number is 22. So binary is a little bit different. So here I have my 22-foot building again, but this time I'm going to climb it with binary ladders. And binary is a little bit different. Instead of using 1, 10, 100, 1,000, 10,000, I'm going to use 1, 2, 4, 8, 16, 32, and so on. Now, I don't really need the 32-foot tall ladder because that's going to be too tall. Just like I didn't need the 100 or the 1,000-foot ladder. So, how many 16-foot ladders am I going to need? Well, let's find out. I'm going to use a 16-foot ladder. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if I'm trying to get up to 22 and I've gone 16, well, that means I have 6 feet left to go. Is the 8-foot ladder going to help me? No, that's going to take me up here. That's too far. I'm going to fall off. So I'm not going to use that 8-foot ladder. Can I use a 4-foot ladder? Sure. I can stick a 4-foot ladder on here. 1, 2, 3, 4. So I had 6. I went up 4, which leaves me just 2 to go. So I'm going to use a 16-foot and a 4-foot. And I only have 2 to go, so if I stick this 2-foot ladder on top, that's going to get me right to the top. And I don't even need my 1-foot ladder. And you have just written your first binary number. 10110 is the binary representation of 22 feet. So let's try that again. We're going to convert the number 22 into binary. In order to do that, we need to write the numbers 1, 2, 4, 8, 16, 32 along the top of our paper. And you'll notice that each time you go over a column, you multiply by 2. Times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So, how do I convert 22 into ones and zeros? The first step is to pick the biggest number out of all of these that fits into 22. Does 32 fit into 22? No, it doesn't. Does 16 fit into 22? Yeah, it does. Let's use 16. So if I use 16, how much do I have left? Well, 22 minus 16 is 6. Does 8 fit into 6? No, it doesn't, so we're not going to use it. Does 4 fit into 6? Yeah, it does. Let's use that. 6 minus 4 is 2, so I have 2 left to figure out. Well, does 2 fit into 2? Yeah, it fits exactly into 2. That's perfect. So if I have 2 minus 2, I'm left with 0, and I do not need to use the 1. So what I wrote under here is my binary number. All you're doing is picking which numbers add up to 22, and you put a 1 under them. So I used 16, 4, and 2. If I add all of those up, I get 22. Remember to always start from the biggest side. You want to try and find the biggest number that fits into your 22, and then the biggest number that fits into 6, and the biggest number that fits into 2, and so on and so on. So here are our rules. Pick the biggest number that fits and write a 1 under it. Subtract that number out. Pick the next biggest number that fits in whatever is left. Write a 1 under that and subtract that out. Keep doing that over and over until you have nothing left. Fill in all the remaining columns with zeros. So let's try it. Let's pick the number 37. 64 is too big. So let's pick the biggest number that fits in 37. That's 32, and write a 1 under it. Subtract 32 out, and we get 5. Pick the next biggest number. So 16 doesn't fit in 5, 8 doesn't fit in 5, 4 fits in 5, and write a 1 under that. We're going to use 4 and subtract that out. We're left with 1. 2 is too big, but 1 fits. And now we have nothing left. So we'll just fill in the rest of them with zeros. And that is our binary representation of the number 37. Now that we know how to convert decimal to binary, how do we go back to decimal? Well, we're going to use the same tool. We write our numbers 1, 2, 4, 8, 16, 32, and so on in the columns. And say we are given the number 101101. How do we convert that to decimal? Well, we'll write it in the boxes. 101101. We know which numbers we're going to use now, so we have 32, 8, 4, and 1. If we add up all of these numbers, we get 45. And that is the decimal version of that binary number. I hope that helps. If you have any questions, just email Mr. Bartus.